Okay, so we have now arrived at linear regression. In the previous video, if you were able to take a peek at it, we saw that we were talking about a little bit about lines and what they are, different types of slopes. So in class, we said that if we have data, let's say this was my height and my weight, so my x value is my height and my y value is my weight, then I know that I can try to find some sort of correlation between these two variables, okay? Now, what we really want to do, we're going to try to see, is there one line that can best fit all these points? What line can I best fit to minimize my errors? Now, that line is what we're going to call my linear regression line. Okay, so this is a line of best fit, okay? And there are certain requirements to find this line of best fit. Before I find it, I want to make sure that my data is numerical, right? It's quantitative. My graph somewhat looks like a line. So if I have something that looks like parabolic, something like that, then we know that that's not okay. We want to make sure that there's not as many outliers if possible. And we want to make sure that they're independent. Now, we'll talk about this a little bit later. You don't really need to worry about what independence really means. It just means that one particular outcome is not going to affect another one. So don't worry about that yet. So now if we remember, when we're trying to find the equation of a line, we use y equals mx plus b. Now statisticians use it a little bit, use y equals mx plus b a little bit differently. We use y hat equals b plus ax. So basically we replace the m with an a, and we replace this, oh, actually, we left the b by itself, so the b is still the same. Okay, so the only thing that we replace is the m with the a. So a in this case now is our slope. Okay, now this y is what we're going to call y hat. This is what we're going to call my predicted value. So this is predicted. Okay, it's because what we're trying to do, if I wanted to figure out someone else whose height I did not know. So maybe this person is like 62 inches, okay, 62 inches. Like, what could their possible weight be? What is this line going to predict it? Now, it's not going to be perfect, but it will be something. Okay, so just a couple things. B here is what we're going to call my y-intercept, so that hasn't changed. A is now called my slope, is the slope of the line, the rise over the run. Y hat is my predicted y value, and E is what we're going to call my residual. It's sometimes called the error. E just stands for error, I suppose, but all it is just taking the true y value minus the predicted y value. So if I did know what the true value was, I can see how big my error is. Okay, now how do you find the regression equation? This is kind of not really important, but I'll go ahead and just say it anyway. These are the formulas that we use. We will not use them, okay? Will not use. Because instead, we are going to use StatCrunch or a calculator, okay? In order to find A and B. Okay, we're not going to use any formulas by hand. It's horrific. It's not great. Okay, so notice x and y are going to be given. Okay, the x values and the y values, the points are given to us. Okay, because I know if x was height and my y value, that was horrible. If x was height and then my y value was weight, then I know that I can plot them in a scatter plot, and I can just try to find the slope and the y-intercept. Okay, so this is what you need to know for this class and for this module. So what you need to know is that if I give you data, you need to figure out what the regression coefficients are. And whenever this word comes up, I'm just talking about A and B. So find out what the slope is, find out what the y-intercept is. And you also need to know how to interpret the slope and the y-intercept. Okay, so I gave you a little bit about what the y-intercept and the slope is. Here are the interpretations. This is something that I would just ask you to either memorize or write them on your sheet of notes. Here is the interpretation for the slope. For every 1 unit increase in x, so whatever x is, so if x was height, so for every 1 unit increase in x, your predicted, whatever y is, weight will increase or decrease by whatever a is. Okay, so when we do an example, this will make sense. Same thing with the y-intercept. When the x value is 0, the predicted y is whatever the b value is. Okay, so this, make sure that you write it down. Okay, so Here I gave you a couple directions on how do we find the regression coefficients A and B. So this is only for the TI-36X Pro. So go ahead and do it. In this video, I will do it using the graphing calculator. Okay. So let me go ahead and just jump right in to the problem, so that way you guys can see how do we calculate A and B. So given the following data, okay, so we have 4 observations, 2 different variables. We want to see height and weight. So we know that we were graphing height and we were graphing weight, and we have 4 different variables. They're 4 different observations. They're probably not going to be in the straight line, but you know what we want to figure out, we want to find a line of best fit. So we want to find the linear regression equation that best fits this line. Okay, so for those that have the TI-36, follow these directions, right? And for those that have the graphing calculator, I will do it here with you. So the first thing that you want to do when you have the graphing calculator, okay, I will go ahead and first turn this thing on. I will go into my stat button. So click on stat. Then I'm going to go ahead and click on the edit button because I have to go ahead and put in my data. So the first one is a 65. Then I have a 63, 70, and the 67. Okay, so that's my first one. And then after that, all of these correspond with 130, okay, 145, 160, and then a 140. Okay, so this is what I have. So now I have my data here, my height and my weight. So if you have the TI-36, follow the directions. Okay, then after that, what you're going to press stat again. Okay, and then you're going to click on the right button on calculate, and then you're going to go down to linear regression. Okay, AX plus B. And I'm going to press enter. And then all of this is just telling you where your data is at. So I'm going to put this and calculate. Okay, and then it tells you what A and B is. So my A is equal to 2.66 and my B equals to negative 32.71. Okay, so A was 2.66 and my B was, what was it again? Negative 32.71. Okay, so that's what we got. Okay, so what we want to do now, we want to find the linear regression equation. So remember, if you look at the equation, if you go back up, my linear regression equation looks something like this. Okay, so we want to plug in the B and the A in there. So this is how we're going to write it. We're going to write Y hat is equal to B plus AX. And what was B equal to? B was equal to negative 32.71 plus 2.66 times X, okay? And this is my answer, okay? So remember, Y hat, in this case, is the predicted weight, okay? And X, in this case, is going to be my height, okay? So X, in this case, is my height. My Y hat is my predicted weight. So if I drew my 4 different points here, then this line represents this equation, okay? All right, so what does the slope in the Y-intercept represent? Okay, so first of all, we have to go back and see what exactly my slope and my Y-intercept represent. So I can just go ahead and write down this: for every 1 unit increase in whatever X is, your predicted, whatever Y is, increases or decreases by whatever that is. Now, if we look at A, so if I looked at my slope, I'm going to write slope. So my slope is going to be, all right, so for every 1 unit, so for every 1 unit in whatever X is, so X in this case is height, so for every 1 unit in height, or every inch, 1 inch in height, my predicted weight, okay, in this case, increases or decreases? Well, my slope in this case is 2.66 and it's positive, so my weight increases by 2.66. That is what this A stands for, the slope. So for every 1 unit increase in height, my predicted weight increases by 2.66, and then in this case is pounds. Okay, so now if we talk about my Y-intercept, Okay, so my y-intercept is going to be a little bit different because now is when x is 0, you have my y-intercept. So when my height is 0 inches, my predicted weight, okay, what would my predicted weight be in this case? My predicted weight will be whatever b is negative 32.71 pounds. Now this makes absolutely no sense. And it makes sense because we're only doing it based on these data points. So I don't really know what's going on past 63, no, before 63 and past 70. So this actually makes no sense. Okay, so the tool will just give you the general picture, but it won't. It's up to you to make sure if it makes sense or not. Okay, so then it says, what is the predicted weight of someone who has a height of 62 inches? Well, I know my regression equation. My regression equation is y hat equals negative 32.71 plus 2.66x. So I want to figure out what is someone's weight if I got someone who's 62. Okay, so y hat is going to be equal to negative 32.71 plus 2.66, and I'm going to plug in that value of x. And this value of x that I'm looking for is going to be 62. Okay, so what is this going to give me? So I'm going to put it in my calculator, negative 32.71 plus 2.66 times 62. All right, and this is going to give me 132.21 pounds. So someone who is about 62 inches will weigh about this. Okay, now is this true? No, because remember there's some variability. It's not a perfect graph, but it's the best. It's not a perfect line, but it's the best line that we can get. So that is one type of problem that might be on your exam. Review it if you need to, and then I'll continue on in the next video.